Right. So, the loc and iloc indexers are tools that you will need in your practice a lot. That's why in this lecture, we'll add a few additional comments on using them. We'll go through a couple of exercises, as well as reenact some situations to avoid while coding. Of course, we'll need a dataset to work on. Let's use the lending company CSV data once again. First, we import and copy it. Then, we'll store it into a variable called lending company data. Moreover, we'll set loan ID as our index column initially. This means that the rows in our data frame will be numbered with all integers between 1 and 1043 inclusive. Besides, the shape attribute confirms we're having a data table with 1043 rows. It also states that our data frame has been composed of 14 columns, the index column excluded. The last output we've obtained is telling us that if we specify an integer beyond the interval of 0, and, please note, 1042 as a row specifier, we will obtain an error message. That's exactly what will be displayed if we execute the iloc accessor with a row specifier of 1043, or say 10,000. That's also why the last row of the error message will read single positional indexer is out of bounds. We will obtain the same error if we try to access the column at position 14. Again, please don't forget that due to the array-like structure of the data frame, we start counting from 0. So, if we wanted to refer to the last column from our data frame, we should have colon, comma, 13, or just colon, comma, -1 within the square brackets of the iloc indexer. Right. The Python syntax allows us to combine several different techniques to access a specific data point. However, we should always look for simplicity when coding in Python. This means that all possibilities out there will usually boil down to a single option or approach that can be considered Pythonic. And the Pythonic way means working with code that doesn't just use syntax correctly, but also lets us express our intentions clearly and explicitly. Hence, for the remainder of the lecture, we'll examine different ways of obtaining a certain result. Though most of the approaches you'll see are valid examples of using Python syntax correctly, only a few will be deemed Pythonic. However, we believe that exploring a variety of approaches is a necessary step before we can appreciate the beauty of truly Pythonic techniques. Now that the framework is clear, let's pick the total price value of the first loan as our target. That is, the data point we will try to access in several ways. The value itself is the number 17,600. Let's first try using the indexing operator to obtain the values from the total price column in the form of a series. Then, we will use the iloc accessor to indicate that we're interested in the first value of the selection. We can try that out by writing 0, colon in the brackets. This code will lead to an error stating that we've used too many indexers. So, here's the first comment we'd like to make. You can apply the iloc accessor to a series, but in such a circumstance, you can only use the single indexer. More precisely, that's the row specifier. Don't provide a column specifier in that case. Therefore, if we remove the comma and the colon from the iloc indexer, we will obtain the desired output. However, you might wonder, why do we need iloc at all? Can't we index the row of interest by using just the indexing operator once more? We can, but in that case, we should be very careful about the values we currently have in the index column of our data frame. Here's what I mean. You might expect to obtain the same output if you provided 0 in the second pair of brackets here. This, however, leads to an error message, showing that namely, the value of 0 was an unclear indication in this execution. So, the source of the error is the state of our index column. Since we've set the index column explicitly, Python will automatically treat its values as labels. So, to obtain the desired value, we need to place the exact loan ID number within the brackets. In our case, that's number 1. Now, we do obtain the desired result. Great! Alternatively, knowing that our index values are all labels, we can obtain the same output by applying the loc accessor with the same index of 1 right after obtaining the total price series, so to speak. More importantly, please note how using iloc or loc helped us to be specific in this situation. They allowed us to clearly indicate whether we mean implicit integer positions or explicit labels. That's why we advise you to use these accessors. They work predictably and are strictly used for integer or label location respectively. Moreover, they help you avoid issues related to specifying names in the form of strings. To explore the same operations in the other scenario, let's re-import the lending company dataset with the only difference that we'll choose string ID as our index column this time. The values stored in the string ID column are composed of the words loan ID, an underscore, and the same numeric value as the one contained in the loan ID column itself. So the idea is to practice with an index column composed of labels that are not just numbers, while at the same time indicate which row of the dataset we'll be referring to. Surely, nothing can go wrong if we rely on iloc with an integer or loc with a label within the square brackets. We will obtain 17,600 directly. Excellent. Problems arise only if we try to use the indexing operator a second time in the same line of code. You may have already realized this technique is similar to attribute or method chaining because of the repeated use of a certain tool in the same line of code. We could say we've chained another indexing operator to the first one. As a consequence, this technique is called chained indexing. So, if we chain an indexing operator with a value of 0 between the brackets to the total price column, we will obtain the desired value. This means that Python can understand we want to refer to the first row of the series. But if I scroll up a few code cells, you can see this wasn't the case earlier when we used loan ID as our index column. The reason being that 0 is treated as a label, which consequently led to an error. To solidify your understanding of how chained indexing works, you can replace 0 with 1 and you will obtain the total price for observation number 2. To refer to the index label, in the second pair of square brackets, you can indicate the correct name directly, which is loan ID 1. Again, you'll obtain 17,600. Therefore, you can trust the strict iloc and loc indexers for position and label-based indexing, respectively. However, do avoid using chained indexing. It may not just lead to the non-desired output because of the confusing way in which it operates. The docs also advise us to avoid this technique, since it can potentially deter the performance of a given execution. In addition, remember that we should be very careful when assigning numbers as index labels in the index column of our data frame. Doing that can turn out to be very confusing for the programmer, who may end up working with the wrong portion of the data eventually. For example, if you plan to use consecutive numbers as labels, such as the ones contained in the loan ID column, this can signify potential trouble. You saw that in our chained indexing example, where we referred to the 0th row in our selection. So, this is a technique that you should avoid, considering that you can just use iloc in that case. Nevertheless, there are circumstances under which your labels will indeed contain numeric values only. Usually, these regard indices containing non-consecutive numbers. In that case, it could be considered appropriate to store numeric values within your labels. Okay. Let's go over a few additional comments regarding the use of iloc and loc. Perhaps even more confusingly, Python allows us to use chained indexing and the iloc or loc indexers together. For instance, we can apply iloc and then have 0 and 5 in separate pairs of brackets. Of course, we don't really need chained indexing here either, since we can obtain the same output by using iloc. To successfully do that, we need to provide 0 as a row specifier and 5 as a column specifier within the brackets. Here, it's important to check how many pairs of square brackets you surround the specifiers by. For example, if you add another pair of brackets around the indexing operator here, you'll obtain a data frame, not just a single value. To avoid such confusion, don't forget to put a comma, space, and a colon before the second closing bracket. The last two comments apply when we are referring to labels as opposition to positions. Chained indexing should be avoided as well, since we can obtain the same output by using the loc accessor by providing loan ID 1 and total price as a row and column specifier, respectively. Moreover, we could also obtain a data frame by surrounding our indexing operator with another pair of brackets. We add a comma, space, and a colon between the two closing brackets, as this is the advised approach. Just make sure you are only using row labels within your list. For instance, you don't need a column name here, such as total price. Instead, you can try out with loan IDs 1 and 6. Considering that loc can deliver the desired total price value for loan ID 1, We also suggest you avoid using the attribute operator to access the total price column, followed by the indexing operator to indicate the observation of interest. The reason is that in terms of operability, that's similar to chained indexing. All right. Choosing an explicit and clear technique for data selection is what you should be always aiming for. Therefore, try to narrow down accessing information from a data frame to only using iloc or loc when you want to refer to integer positions or index labels respectively. Perhaps the only situation where you can combine iloc and loc is if you want to refer to the positions of certain values in a data frame column, or in other words, a series. Still, we will advise you to be explicit and use loc to indicate you're interested in the total price column, and only then use iloc to specify the rows of interest. We would also like to remind you that good practice requires us to use a colon to indicate we are interested in all column values. Moreover, here iloc can be used with a single indexer only. This can be a single value or a list. Here's an example with a list containing the values 0 and 5. Okay, we hope this was a useful exercise on various Python techniques for indexing data. But more importantly, we think it was the step we needed to help you understand why accessing portions of your data frame via positions or labels via the iloc or loc indexers is the preferred approach. By being explicit when selecting data, you can aid yourself, your colleagues, and even Python obtain the desired information more efficiently and quickly. Thank you for watching.